highest priority. It must be the first flow through the structure. And therefore, the related spillway is very low. And usually this spillway, the regulation in force doesn't allow to put a gate here because they don't want the flow through the environmental flow spillway to be regulated. They don't want the environmental flow to be regulated. It must be given for sure. It must be granted for sure. And here, with these signs, with these vertical lines, I indicated the wings, because usually the main spillway, as I said, takes place in the central part of the barrage, and here the wings are used to connect the central part of the spillway with the upper parts that are placed close to the heel slopes. And then, of course, here the spillway of the environmental flow is again depressed. Because from here you are at a given altitude, and then you increase along the wings, and then you get to the place where the gate of the spillway of the environmental flow is located at a lower altitude with respect to the main spillway. And then other features are another spillway, the diversion spillway, which is usually protected with gates. And the sequence of flows is as follows. First, high priority to the environmental flow. When the environmental flow is granted, then the diversion spillways start working and start getting water. When the design flow is reached through the diversion spillways, the flow in excess starts to pass over the main spillway. So this is the sequence: environmental flow spillway, diversion spillway, main spillway. The diverted flow gets into a gravel trap, which allows the settlement of the gravel, and then through a step, because the gravel trap is limited by a step from the bottom, through surmounting a step, water gets into the sand trap, where we remove the sand. So this basin, which is usually a very long basin, allows the settlement of suspended material up to a certain diameter that is usually fixed by looking at the features of the turbine, by looking at the water use. After the sand trap, water gets into an upstream tank. This is not always present. The upstream tank is used when water is conveyed downstream through a pipe. And if water is conveyed downstream through a pipe, you don't want air into the pipe, because otherwise the presence of air and water causes a damage to the pipe, and therefore you build a tank here to make sure that you have that the pipe is always well submerged. The sand trap is equipped with a top spillway, it's an overflow spillway, and flushing sluiceways. Sluiceways are bottom discharges, and these are used in order to flush water to clean the structure. And usually the sand trap is divided into two channels in order to be able to clean one and then the other without interrupting the flow. Okay, other features are the protections from erosion, usually large boulders or some basin. And other features are the foundations, which are not depicted here, but we see here what I call lateral bindings. Usually you have longitudinal walls in order, like this one, and the upper one, which build the main structure of the barrage. And these longitudinal walls are binded to the hill slopes with some structures in order to make sure that the whole structure is stable, is not flushed downstream by floods. I think this is, I mentioned everything, so I think we can stop here. Next time we will focus on how to design the structure from the hydraulic point of view. Good.